Okay, so in this example, it says a rotating light is located 10 feet from a wall. The light completes one rotation every 3 seconds. Find the rate at which the light projected into the wall is moving along the wall when the light's angle is 10 degrees from perpendicular to the wall. Okay. So let's make sure we're clear first off. So the light, you see the picture here, there's the light, here's the wall. The light is located 10 feet from the wall. That means this is 10. You might wonder, well, how do you know it's not like that? Well, because whenever we say how far something is from something, we mean straight at it, meaning at 90 degrees, right? That's what it means when we say how far is this point, because you could, if you don't do that, then you could say, well, it's way over here. It's really far from the wall, right? That's not what we mean. The definition of distance between two things is a straight line, meaning 90 degrees. So this makes this a little right triangle right here. And the 10 is not here. It's here. So there's the 10. Okay. Now, the light well, here, let's go through. That's probably enough with our diagram. Let's go through the steps. So you know what we're supposed to do, right? Step number one is to identify the rate variables. Identify the rate variables or letters. So, what are the things where they talk about rates? Well, one rotation every 3 seconds. That's how fast it's happening, right? It's how fast the light is rotating. That's, in fact, d theta dt. This is theta right here. This is the angle between straight at the wall and, because basically you get this light and it's shining on the wall, but it's rotating. So as this light, rotates around, just keeps rotating around, um, the light, when it's like a siren or something, like where you see a siren and it's rotating around. And, when it comes around here, the light shines on the wall and goes down the wall, doesn't it? So we're wondering, they're saying the light completes one rotation every 3 seconds. So that's how fast the angle is changing. So that's one rotation every 3 seconds. One rotation. Sorry, can I spell that sloppy? More sloppy than usual. All right, fell in trouble. One rotation every 3 seconds. Now, Um, I need to put that in an angle. So what I could do is you could say, well, isn't that 360 degrees every 3 seconds? Because that's all the way around. Yes, but we have to make it 2 pi radians. Why? Well, because whenever we're doing calculus and if you deal with just write it up here. Sine, cosine, tangent, etc. The trig functions. You might if you're gonna do the derivatives, which we're gonna do, that's rate of change. Derivatives only in radians. I don't know if you remember earlier, but all the derivative rules we learned for the trig functions, like derivative sine is cosine, or derivative cosine is negative sine, all those rules are only true in radians. Now, you might wonder, well, how do you know 2 pi? So I put a little unit circle here. So look at a little unit circle. Here we go. This is one I give to my trig students. Feel free to copy it and use it, whatever. You can put it on your 3x5 card for the exam or whatever. All the way around is 360 degrees or 2 pi radians, right? Halfway around is pi radians. This is a nice little unit circle. Again, this is the one I give trig, has all the values and everything. It's kind of nice. We can use calculators too for everything. But in this case, it's just nice to know. One rotation is 2 pi radians. And it goes through 2 pi radians all the way around every 3 seconds. That's d theta dt. That's how fast the angle changes. That's the change in theta. D stands for difference when we do derivatives. Difference in theta over the difference in time. The angle changes by 2 pi radians or 360 degrees, same thing, every 3 seconds. So I'm identifying the rate variables. So there's the first one, d theta dt is 2 pi over 3 radians per second. Okay, what other rate variable do we got here? They say find the rate at which the light projected into the wall is moving. How fast? So this light, which will be shining right here, is moving along the wall. So let's call this X. Call it whatever you want. I just made up a letter. They want us to find dx dt. That's what they're asking us to find, right? They're saying find the rate at which the light projected on the wall is moving along the wall. Okay, that's what they want. So we got our two rate variables. That's the first step. Identify the two or sometimes three rate variables. So we know what they're giving us. They're giving us d theta dt is 2 pi over 3 radians, 2 pi radians every 3 seconds. They want us to find, so that's how fast the angle is rotating. They want us to find how fast is the light on the wall moving, dx dt, where x is the distance along the wall. Okay, so step two, to identify the rate variable. Step two, find an equation. Find an equation, you remember, right? Relating those letters, right? That's why it's called related rates. So first so what letters? In this case, theta and x, right? D theta, dx. So they're always dt on the bottom, of course. It's time. That's what a rate means, how fast something happens in time. So we need some kind of equation between theta and x. What's that going to be? Well, you probably know already, right? So right there, this is the opposite side of theta. That's opposite the angle theta. This side here is the hypotenuse because it's across from the right angle, which makes this side the adjacent. Okay, so I'm going to use one of those trig functions. You remember SOHCAHTOA from trigonometry, SOHCAHTOA, right? SOHCAHTOA. Okay. So um this angle theta here, so which two sides are we looking at? That side and that side. We don't know anything about the hypotenuse. I'm not gonna use hypotenuse at all. I want to find x, and I got the 10. So this is how you, because students often ask me, Mr. How do you know which truth is? Sine, cosine, tangent, how do you know? Well, you just look at the two sides you have, or you want to know, whatever. X, I want to know 10 I have. I don't know anything about the hypotenuse. So x and 10, that's what? Opposite and adjacent. Which one of these trig functions is opposite and adjacent? Tangent. So that's tangent I want. So there's my equation. The tangent of theta is x over 10 because that's opposite over adjacent, right? X is opposite, adjacent is 10. So there it is. There's an equation relating theta and x. Theta on this side, x on that side. Got it. Okay. Step three, um, take the d dt of both sides. So I'm going to take that equation down here, tan theta on the other side. Oh, I'm going to rewrite this as 1/10 x because I don't like fractions that have an x in them. So now I just put a fraction in the front, x alone, right? Just going to rewrite that to make it nicer. So I don't want to deal with the quotient rule. I don't want fractions. I don't want a fraction that has x as part of it. You might say, well, you still got a fraction. Yeah, but x is not part of that fraction any longer. Fractions that are just numbers, that's no big deal. That's just a spectator sitting there watching the derivative happen. But if you have this, then x is involved in your fraction. Then you got to do the quotient rule. I don't want to go there. So I rewrite it. All right. So I'm going to take d dt of this side and d dt of that side. What happens on this side? Well, the derivative tangent is secant squared of theta times derivative of the inside, d theta dt. You good there? So I did the derivative of the outside, which is derivative of tangent secant squared. Keep the inside the same at first, times the derivative of the inside function, d theta dt. How about this one? Well, the 1/10 just sits there. And the derivative of x, that's easy. It's just dx dt. Oh. So this is technically related rates. Now, see how I've got this rate, and they're in a relationship, an equation. meaning secant squared theta times this rate is 1/10 times that rate. That's a related rate. So now, step four, plug in your numbers. Plug in your numbers. Okay. What numbers? Well, first off, oh, I know the angle. When the light's angle is 10 degrees. So this angle right here is 10 degrees. So I can just come on down here and go 10 degrees. You know better than that, huh? No degrees, right? I got to change to radians. So now how do you do that? Well, 10 degrees. That's where, do you remember how to, can you put this over one? Whenever you want to convert units, you learn, here's how you convert units. So you put that over one just to make it look like a fraction. It's 10 degrees over one. And now you want to convert. Well, how do you convert? Remember this from trigonometry between radians and degrees? Here's the easy way. Half a circle. Oops, a little bit too far, right? There is pi. It's also 180. Pi and 180 are the same thing. They're just in two different languages. Kind of like uno and one. You're saying the same number in two different languages, right? 180 and pi. In both cases, you're saying half a circle. So that's how we convert. That's easy. Nate, you think, well, can we just do 360 and 2 pi? Yeah, you totally could. That'd work too. But the easiest thing is just 180 and pi because that way, I mean, yeah, either way. I don't know if it's easier, but I just always use pi and 180. You can totally use 2 pi and 360. Yeah, maybe that'd be easier. Yeah, since you're used to it, huh? Yeah, let's just do that. Maybe I'm probably confusing you. Yeah, just do that. Just go, okay, well, I'll just say all the way around is 2 pi and it's 360. Those are the same thing. 2 pi radians is 360 degrees. So just go back and go, okay. So that means, now how do you know where things go? Well, here's the secret. You want to put the degrees down here. Why? Because you want degrees to cancel and 2 pi radians up there because you want to change to radians. One more time, really important that you learn how to convert these. I learned it in chemistry 3A when I was at community college. So this is how we convert units. Whatever you have on the top, put it over one and put that same thing down below and they'll cross cancel. Unit, that was news to me. Units cross cancel just like numbers do. So if you have degrees up here, then you want degrees down there. And then this is just the same thing. 2 pi radians and 360, they're the same thing. So it's a fancy one, in other words. So I'm not changing the value, I'm changing the units. So the degrees will cancel. And what do you get? Now you just multiply straight. 10 times 2 pi, that's 20 pi over 360. Could you reduce that? Yeah, but who cares? Who cares? We're going to let the Desmos calculator do the work. That's my radians. I'm not going to get decimals or reduce it. Who cares? That is 10 degrees now in radians. I'll just say, I mean, just to make sure we're clear, this is the same as 10 degrees. This is you can hit the buttons in the calculator, get some decimal. I'm not going to bother. I'm going to let Desmos do all the work in a minute. That's the radians. So it makes sense what I did there. I converted. So right here, maybe I should have written know what I'm doing. I'm changing 10 degrees to radians because everything's got to be in radians. So I put degrees on the top and degrees on the bottom so that they cross canceled. They're out of there. What's left is radians. 2 pi radians all the way around is the same as 360 degrees. Then just multiply straight. There we go. So I changed that to radians. So this angle then, 10 degrees, is the same as, what was it? 20 pi over 360 radians. So that's my theta angle. That's my theta now in radians. 20 pi over 360. Okay, back to the problem. Okay, so bringing this baby down here, we have secant squared of, what's my angle? 20 pi over 360 radians times d theta dt. That's up here somewhere, isn't it? D theta dt is 2 pi over 3 radians per second. So I'll put that there. So this right here is 2 pi over 3 equals, and then bring down the 1/10 times, and then there's dx dt, which we're trying to find, huh? All right. And so now both sides just divide by the 1/10. Boom, boom. 1/10. And dx/dt alone. Let's go to Desmos and hit the buttons on your calculator. Secant squared, 20 pi over 360. Oh, wait a minute. Desmos doesn't have secant. So, oh yeah, yeah. So we're gonna, I mean, well, maybe it does. I don't know, does it? Let's go see. I can't remember. We can change the cosine if it doesn't. Oh, does it function? No, it doesn't. Okay, yeah, we'll change it. All right, let's go back. So we're gonna change this bad boy. So remember, do you remember? Secant is upside down cosine. So this is gonna go down here and become cosine squared of 20 pi over 360. That's the same thing. Secant is upside down cosine. You remember that from trig? Remember, let me write these out if this is helpful for you. Sine, cosine, tangent, and then you just flip, 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 and you get cosecant, secant, cotan. Remember that? Flip, flip, flip. It's just upside down. So cosine is just upside down of secant. So if you have secant on the top, that's the same thing as cosine on the bottom. Secant squared, same as cosine squared. Just move it to the bottom. So yeah, so there's what I'm going to type into Desmos. This, right? Does that make sense? So let's get 2 pi over 3 on the top. All right, here we go. A big old, back to the main, big old fraction. 2 pi over 3 over. And now what's the bottom? Bottom had like a tenth. A tenth, so now I'll do this tenth. Whoops. Pen there. A tenth cosine squared, 20 pi over 360. Tenth. Oh, I have to like cosine. Oh yeah, to do the squared, yeah, you're gonna have to do parentheses. Parenthesis, cosine, what was it? 20 pi over 360. 20 pi over 360. There and there, squared. Okay. And there's my answer, and it's incorrect. Why is it incorrect? I'm not, see my mode? I'm in degrees, not radians. Change to radians. There we go. See the answer changed a little bit, not much, huh? So I hit the radians button. There it is. So let's go see this right. 21.595. 21.595. Is that what the answer is? Oh, that's beautiful. I love it when we get it right. 21.595. There we go. So does that make sense? I just typed this in because I let the secant squared go down there. And there we go. We got dx/dt. That's how fast that light on the wall is moving 21.6 basically feet every second. That's how fast. Right when it's here actually, right? Because it's at 10 degrees. So that light's moving, and you know how it moves faster as it goes down. You've seen that before with a siren, like against a wall. You know, it goes zoom, faster. So it's going to depend on where it's at. When it's at 10 degrees, it's moving 21.6 feet per second along that wall. All right, that's a tough one. And there we go.